Today we will be talking about integration using trig integrals. Let's look at an example. We have the integral of sine x squared times cos x cubed from 0 to pi over 2. First, let's write all the trig identities we will use since we need them for this method of integration. So we have sine x squared is equal to 1 minus cos x squared. Cos x squared is equal to 1 minus sine x squared. Sine x squared is equal to 1 minus cos 2x divided by 2. Cos x squared is equal to 1 plus cos 2x divided by 2. Sine 2x is equal to 2 sine x cos x. Tan x squared is equal to secant x squared minus 1, and secant x squared is equal to tan x squared plus 1. Next, we will look at our integral and reorganize the integral to become sine x squared times cos x since we can do more with cos x squared. Now we can change cos x squared to 1 minus sine x squared, and then we can make u equal sine x. So du will become cos x dx, then isolate for dx to get du over cos x. When we make these changes, we will get u squared times 1 minus u squared times cos x times du over cos x. We now can cancel the cos x, and all we have to do is distribute u squared into the brackets and integrate. Then you will get u squared minus u to the power of 4, meaning the integral will be u cubed over 3 minus u to the power of 5 over 5. Now sub sine x back for u, and you will get sine x cubed over 3 minus sine x to the power of 5 over 5. The last step is evaluating the integral, so we sub in pi over 2 and 0 for antiderivative and subtract them to get 2 over 15 as the final answer. The steps to integrate using trig integrals are very similar. You just have to organize and break the integral to where you can sub an identity, and that identity you sub in will be the one equal to u. And when you do so, there is a good chance that du will be the derivative that will cancel something in the integral to simplify it. Let's look at our next example. So we have the integral of cos x to the power of 4. To use the identities, we will break the integral to cos x squared times cos x squared, and we will sub in the identity cos x squared is equal to 1 plus cos 2x over 2. We will multiply them to get 1 plus 2 cos 2x plus cos 2x squared over 4. Now we can factor the 1 over 4 to make it easier to integrate. Now if you look at it, you will notice you can integrate each variable easily because they are being added, except for the cos 2x squared. So we will use the sum identity. So half times cos 2x will equal to cos 2x minus 2x plus cos 2x plus 2x. This will give you cos 0, which is 1 plus cos 4x over 2. So cos 2x squared is equal to 1 plus cos 4x over 2. Now when we sub it back into the integral, we will break the fraction into 1 over 2 and cos 4x over 2 to make easy to integrate. Now we can easily integrate. We will get x plus 2 times sine 2x over 2, where the 2 will cancel, plus 1 over 2x plus sine 4x over 2 times 4. After we multiply by 1 over 4 and simplify, we get that the final answer is sine 4x plus 8 sine 2x plus 12x over 32 plus c. You do not have to simplify like this unless you want to or are asked to. Let's look at another example. We have the integral of sine x cubed. To be able to use the trig identities, we will make the integral sine x squared times sine x. Now sine x squared is equal to 1 minus cos x squared. Now we can let u equal to cos x, and du will be negative sine x. Isolate for dx, and you get negative du over sine x. Now sub those in, and we get the integral of 1 minus u squared times sine x times du over negative sine x. And we can see that the sine x will cancel because they are being divided by each other. So then distribute the negative 1 into the bracket, and all we are left with is negative 1 plus u squared. Now we can integrate this easily. The antiderivative of negative 1 is just negative u, and the antiderivative of u squared is u cubed divided by 3. The last step is subbing cos x back in for u and adding the constant c. So our final answer is negative cos x plus cos x cubed divided by 3 plus c. The next example is the integral of tan x cubed times secant x cubed. We will break tan x cubed to tan x and tan x squared, which will equal to secant x squared minus 1, and break secant x cubed into secant x and secant x squared. This way, when u is equal to secant x and du is equal to tan x secant x, the tan x secant x will be cancelled. And after multiplying u squared into the brackets, we will be left with the integral of u to the power of 4 minus u squared, which equals to u to the power of 5 over 5 minus u cubed over 3. Then we sub secant back into u to get that our final answer is secant x to the power of 5 over 5 minus secant x cubed over 3 plus c. The next example is the integral of the square root of tan x times secant x to the power of 4 from 0 to pi over 4. The best way to solve is breaking secant x to the power of 4 into secant x squared times secant x squared, then subbing tan x squared plus 1 into only one of them so that we can cancel the secant x squared. So we will make tan x equal to u. So du is equal to secant x squared dx. Isolate for dx, and you get du over secant x squared. This will give us the integral of the square root of u times u squared plus 1 times secant x squared times du over secant x squared. Now we can cancel secant x squared, and then distribute the square root of u, which is just u to the power of half, into the brackets to get u to the power of 5 over 2 plus u to the power of half. Now to integrate this, we add 1 the exponent and multiply u by the reciprocal of the exponent fraction. So 5 over 2 plus 1 is 7 over 2. And to cancel 7 over 2, then we multiply u by 2 over 7, and if we differentiate this, we should get u to the power of 5 over 2. And the integral of u to the power of half is 2 over 3 times u to the power of 3 over 2. Now we sub tan x back for u, and we should evaluate from 0 to pi over 4. When we sub tan x back in, we will break the exponents to make easier to evaluate. We will break tan x to the power of 7 over 2 into tan x cubed times tan x to the power of half, which is just the square root of tan x, and times 2 over 7. Then break tan x to the power of 3 over 2 into tan x times tan x to the power of half, which is also just the square root of tan x, and times 2 over 3. Now we sub pi over 4, then sub 0, and subtract them. Tan pi over 4 is 1, and tan 0 is just 0. So for the tan 0 evaluation part, the whole thing will be 0. So we will be left with 2 over 7 plus 2 over 3. We find a common denominator, which is 21, and then add the fractions to get 20 over 21. Let's look at one more example. We have the integral of tan x cubed times secant x to the power of 4. The first step is to decide which variables we want to reorganize so we can use trig identities. We will make the integral tan x cubed times secant x squared times secant x squared. This way we can sub tan x squared plus 1 for secant x squared. We will leave the other secant x squared and let u equal tan x. This way du will be equal to secant x squared dx. And when you isolate for dx, you will get du over secant x squared. Now we sub these back in the integral, and we see that the secant squared x cancels, and we will be left with the integral of u to the power of 5 plus u cubed. This now is very easy to integrate. We will get u to the power of 6 divided by 6 plus u to the power of 4 divided by 4. And the last step will be subbing tan x for u and adding the constant c. So our final answer will be tan x to the power of 6 divided by 6 plus tan x to the power of 4 divided by 4 plus c.